So now we are going to define what is called odds ratio. So odds ratio is defined by as the proportional improvement in odds. Okay, so we computed odds, right? So when you change the x value, the odds changes. The L changes, so odds would change. If x value changes, odds will change naturally, because otherwise it's not doing anything to your y. So when the x values change, the probabilities change, and when probabilities change, the odds change, right? So is there a pattern in the changing of the value of the odds? So that's what we're going to look at now. Suppose if the income, the x value, whatever the x value may be, goes up by 1, what happens to the odds? Maybe that's where the interpretation for the slope coefficient is going to come from. Because remember, in the regular classical regression, that's what slope coefficient does. It tells us what will be the change in value of y for an increase of 1 unit in the value of x. So that's the interpretation for regular regression. So is there something similar in logistic regression? If the x value increases by 1, so what happens to the odds? Okay, so let's again, here I think we can copy these 3 formulas. Well, actually all of them. Okay, like that. Okay, and copy that down. So when the income goes up by 1, the odds, okay, changes from that to that. Okay. So now if you find a ratio of that, okay, so now we get what is called odds ratio. If x goes up by 1, the odds of success increases at the rate of this. So it so happens that odds ratio is, no matter where we start, right, this odds ratio will always be the same. So let's see, so I'm going to copy paste the value here, right? So we know what, okay, so that's the odds ratio when we go from 100 to 101. Suppose if we go from 200 to 201, you see the odds ratio is exactly the same. So it doesn't matter where the x value is at, okay, irrespective of that, when the value of x increases by 1, the change in odds, the multiple, okay, so it will always increase at this rate. So it increases by 3.78%. Okay. So odds ratio gives us what will happen to odds, okay, when x increases by 1 unit in value. And here is where we see that, okay, when you do EXP of the slope coefficient, okay, e to the power of b, you get the odds ratio. So we can now connect some sort of interpretation between the value of b, the slope coefficient that we have estimated, b sub 1. So b sub 1 gives us odds ratio. So now we can interpret the odds ratio as when x goes up by 1, this is what will happen to the odds of success. So that is the connection, that is the interpretation for the slope coefficient. So you come from the slope coefficient, okay, you figure out odds ratio, e to the power of b sub 1. Okay. So in other words, all of this computation is unnecessary. So we did all of these computations to understand odds ratio. Okay, what is odds ratio? We need to understand that first, right? So that's why we went over all these computations. So in practice, what you would do, you will go from the B sub 1 value straight to odds ratio, and then you will do the interpretation, right? So the interpretation here is so B sub 1 is that, and so EXP of that will give you the odds ratio. So here X is income. So if X goes up by 1, okay, so if X goes up by 1, the odds of that the customer will accept the loan offer will increase by factor 1.03782. Okay. Only thing is here, this is not a good interpretation. Okay. The reason for that is that we're saying X goes up by 1. X goes up by 1 doesn't give a good sense of what it is. What is X? Okay. X is income, and it is in what? You have to bring in the units also. You can't say if income goes up by 1. No. If X goes up by 1, so that would mean income will go up by $1,000, because income is in $1,000. So if X goes up by 1, the income will go up by 1. So if X goes up by 1, i.e. income increases by $1,000, okay, then the odds will, again, you need to make sure that the text is justified, okay. So that's odds ratio and how you use that concept to provide an interpretation for slope coefficient. So here, of course, we have only one slope coefficient, but when we get to a larger problem, we'll have a bunch of slope coefficients, and each of the slope coefficients should be converted to an odds ratio. How do you do that? E to the power of the slope coefficient will give you the odds ratio, and then you interpret the odds ratio.